In this lesson, we're going to answer the question, what does it mean? What does it all mean? And in specific, we're going to talk about division. Because division is kind of a familiar concept for us at this point because we've done lots of division. But now we're going to deal with fractions. And fractions can throw a little bit of a loop in there and can get a little confusing. So before we actually start dividing fractions, we need to talk about what does division really mean? And in the case of fractions, what does it look like? So I'm going to start simple. If you look at this top right here, this top sentence says 25 divided by 5. Now hopefully, instead of just jumping right into it and saying, oh, I know the answer to that, we can visualize what exactly that means. If I have 25 of something, let's say I have 25 cookies that I just baked, and I want to share those with 5 of my friends, that means that I'm going to look for a way to divide or split up all of those cookies into equal groups so that each one of my 5 friends gets the same number of cookies. So I'm going to be actually taking this original number, my whole batch of cookies, and giving each of my 5 friends the same number of cookies. Okay? And we know, hopefully conceptually, that when we do that, each one of my friends gets 5 of those. Okay? How do I know that for sure? Well, I can check that with multiplication, and we'll talk about that a little bit later. But now, let's look at a different idea. Let's talk about dividing a fraction. 5 divided by 1/4. Now, it means the same thing. I have an original quantity of 5, and I want to know if I split that up into fourths, how many will there be? Okay? Let's say I only have 5 cookies left, and I want to know how many times can I cut that up into a fourth, and how many will I have? How many fourths will I have? Okay? Now this one, I can actually draw a picture of. Let's say I have 5 cookies. Okay? How many fourths can I cut that up into? Is basically what this question is asking. Another way of asking this, which is a little more mathematical, is how many times does a fourth go into 5? How many fourths can I fit into 5 holes? So here's my 5 holes. And if I cut each one of those into quarters, which shouldn't be too hard, just cutting up each one of these holes into 4 pieces, how many total pieces am I going to have once I'm done cutting them up into fourths, right? And that's simple counting from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I could have also figured that out just by counting 1, 2, 3, 4, 5, and then realizing each one of those has 4 pieces, so 5 times 4 is 20. Now this is interesting, because usually when I divide, my answer is smaller than the original number. But when I'm dividing a fraction, notice my answer is much bigger than my original number. But can you see why? It's because I cut up each one of those holes into 4 pieces, into fourths, and then counted how many fourths I have. This is the big idea behind fraction division. Now you can also relate this to multiplication. I mentioned that a little while ago. Look at this top one again. If I were to write the inverse operation there, basically what I'm doing is I'm checking 5 times 5 is 25. See how I just went backwards? That's something that you've probably practiced before too. Okay? If you have a background in multiplication of fractions, then it should make sense that 20 times a fourth equals 5. If you don't have a background in that, then recognize that when I have a whole number like this, do you know what I can do with any whole number to change it into a fraction? Do you remember? If not, realize that any whole number is already a fraction. with a 1 in the denominator. And then with multiplication, I love multiplication of fractions because it's so easy. Multiply across the top, multiply across the bottom. 20 times 1 is 20. 1 times 4 is 4. And then this is just straight division. 20 divided by 4 is 5. So again, I did the inverse operation. This is 5 divided by 1/4 equals 20. I've turned that inside out, and now it's 20 times 1/4 equals 5. So it's just a backwards thing, okay? But what's really important is that we have a pretty good understanding or a picture of what's going on here. The fact that you had 5 whole things to start with, and you wanted to know how many fourths that is, okay? Let's do one more example of fraction division and see if it conceptually makes sense. And we're gonna draw pictures, of course. Pictures are so good, guys. If you get a chance to practice drawing a picture or setting up some kind of model that you can see what's going on, do it. Such a good idea. Here is a fraction, and I'm gonna divide this fraction by another fraction. Ooh, okay? Let's do 1/2 divided by 1/6. Now the idea is the same. Here's the quantity I'm starting with. I want to know how many times does this quantity fit into there, okay? If I were to cut up this into these pieces, how many of these pieces would there be, okay? So let's draw a picture. Let's draw a picture of a half first. That's not too hard. We know what a half looks like because we can just draw a line straight down the center. Here's a half, here's a half. But since I'm dealing with a half to begin with, I'm basically going to ignore one of these halves, okay? Let's say that I'm going to kind of ignore this half for now. I'm only concerned with this half because I want to know how many sixths are in this half. Now that doesn't mean I get to ignore the whole pie, I'm just not really focused on this side, okay? So kind of like what I did with the cookies where I cut each hole into fourths, this time I'm gonna cut this hole into sixths. So I need to make this whole pie have 6 total pieces. Right now it has 2, right? If I were to draw a line, say here, and then here, does that give me 6 total pieces? 1, 2, 3, 4, 5, 6. Good. Okay? Now again, remember, I'm only really concerned with this half. So now it's just simple counting. How many sixths are in this half right here? 1, 2, 3. Does that make sense? So if I'm starting off with just a half and I want to know how many sixths there are, this model helped me see visually that there are 3. Because in the whole thing, let's say the whole pie, there are 6 sixths, right? But in only half of it, there's half as many. There's only 3. Okay? Now, this is a nice short video because all it is an introduction. If you need to hear it again, go ahead and rewind and watch it again. Right underneath this is some exercises that I'm going to ask you to draw a picture, kind of like we did here, so that you can visualize what this division looks like. And then underneath that is a little bit more deeper thought. So try those and meet me back in the next video underneath the exercises and we'll talk about it a little bit more, okay?